Hello everyone. In this session, we will discuss continuity of a function at any points. So suppose let's f(x) is the function. We are going to check if function f(x) is continuous at x equal to a or not. But before that, let's understood what is the means of continuity at any point. Simply that if we are able to draw the graph of f(x) near to the point a, like here, without taking out the pen from the board like this, then we say function is continuous at x equal to a. This is the simple meaning of the continuity. What is the means of continuity? Simply if you are able to draw the continuous without taking out the pen or taking any point, then we say function is continuous. But suppose if question came, we cannot draw every graph. So how to check if function is continuous or not? Same concept we are using. Suppose if you are moving from here, means what? Left hand limits. If you are moving from here, right hand limits. And this point is value of function. So simply, how to check mathematically any function is continuous at any point A. So simply what we have to say, any function f(x), function f(x) is at a point A if left hand limit means f(x) limit x tend to a equal to right hand limits equal to value of function. Right hand limits means limit x tend to a plus here f. Left hand limit means we are approaching from left side. Right hand limit means we are approaching from right side, and value of function means exact on that point. Then we say function is continuous. So let's draw some graph. It will be more clear. This is the total possibility what it can be. Which type of discontinuity it can be. What is the total possible condition? If you draw the graph, it will be discontinuous or continuous. How it can be? So let's see this. Let's draw the graph. It will be more clear. See this. Suppose first graph it can be like this. Suppose this is the graph and we are checking at point A. This is the point A. See, so if you are moving from left side or you are moving from right side, and at that point both values are equal. Suppose this is the function, then we say it is continuous function. Continuous function. Next what it can be? Next it can be suppose you are moving from left side and you are moving from here. And if you are moving right side, both are equal, but here both values are equal from left side, but exact on that value function exists here. So suppose this is point here. So if you are moving from left side, it is a left hand limits. What it can be? Left hand limit equal to right hand limits, but not equal to value of function. At that time, this what it will be? Discontinuous. Discontinuous, because we just see if both left hand limits and right hand limits both all are equal, left hand limit, right hand limit equal to value of function, then we can say function is continuous. Otherwise it is not continuous. So this is not continuous. Next what it can be? Next can be something like this. Suppose left hand limit, right hand limit exists, but value of function is not equal. At that time this is also discontinuous. Next what it can be? Next can be like left hand limit exists, right hand limit exists, but left hand limit is not equal to right hand limits. At that time we say function is discontinuous. Next what it can be? Next maybe it is left hand limits right hand limits. Left hand limits, right hand limits maybe not exist. Maybe both are not exist, or maybe one is not exist. Left hand limits or right hand limits does not exist. So this is the total all possible case. What a function can be if it is discontinuous. This is the function continuous when left hand limit, right hand limit. Here value of function, here what, left hand limit is not equal to right hand limit, so this is not equal. So this is the total case a function cannot be discontinuous. So if we remember this graph, only 4 5 graph, this represents the total possibility what a function can be, in which way it can be discontinuous. So let's move little bit further. So simply, how many way we can classify discontinuity? So total, let's declassify how many way total we can classify it is discontinuous. So total, what is the criteria? See that, so total there are flowing some cases are there, 3 4 cases what it can be. Total, if it is discontinuous, then maybe first limit x tend to a plus fx equal to limit x tend to a minus fx. The left hand limits are right hand limit. In compared to this, we can write right hand limits are left hand limits does not exist. Does not exist. First case is that left hand limits are right hand limits does not exist. Second case, maybe left hand limits is not equal to right hand limits. Next, what it can be? Third, left hand limits equal to right hand limits but is not equal to value of function. At that time we say function is discontinuous. Next, fourth case, what it can be? Value of function f is not defined, means both left hand limit, right hand limit, all condition is satisfied. Maybe this is what f is not defined. So this is the total. We draw the 4 graph. This is the total thing when function can be discontinuous. So if you remember this is the total criteria how when function can be discontinuous. Let's discuss one by one in detail. So let's discuss first criteria. First, when left hand limits is not equal to right hand limit. So if you draw the graph, it look like this way. Suppose left hand limit is here. If you draw right hand limit, it is here. So from if you move left side, you will reach here. Suppose this is L1. Here L2. Left hand limit, what is coming? L1. Right hand limit L2. So at that time, left hand limit is not equal to right hand limit. At that time also we say limit does not exist. Let's see one example. So here what is we can say limit x, suppose this is the point A, limit x tend to a minus, what is that? L1. Limit x tend to a plus means right hand limits equal to L2. Here L1 is not equal to L2 means what? Limit does not exist. Just let's take one example. Let's take one example of this. Let's draw signum function. Okay. Here, let's fx equal to, it is given mod x upon x. Suppose this is fx equal to mod x upon x. Here we are going to check continuity at x equal to 0. So for here, what we have to take? We have to take left hand limit and right hand limit. So let's calculate first left hand limit. So limit x tend to left hand limit means less tend to 0 minus fx. What is the fx? Limit x tend to 0 minus fx is mod x upon x. And we know that if x is less than 0, mod x will open with negative sign. So what it will be? Limit x tend to 0 minus x upon x. This cancel, we will get minus 1. So our left hand limit is coming minus 1. Now right hand limits, limit x tend to 0 plus fx equal to what? Limit x tend to 0 plus fx is mod x upon x. Here x is positive here, greater than 0. So mod x open with positive sign. So simply what it will come? X upon x, that is equal to 1. See here, left hand limit is coming minus 1, right hand limit is coming 1. So in this case, left hand limits is not equal to the right hand limits. So we say this function is discontinuous at x equal to point A. See, this is the mathematical calculation. Let's draw the graph. It will be more clear. So we can understand geometrically. See, when we see the figure, we remember long time in compared to theoretical written story. So let's draw the graph to understood, make the clearance in our mind. We get clear picture. So at that time we will remember long time. So let's draw the graph. So I'm going to remove this. Let's draw the graph of this thing fx. See here, let's draw the fx. Suppose y-x is, and this is x greater than 0. Suppose if x greater than 0 means x greater than 0 it is positive, x upon x, y equal to 1. Greater than 0 means here we cannot take 0. So we draw like this. And here, if x less than 0, it will open negative and it is minus. So this is, we cannot take 0, so it is minus. See here, left hand limit, if you are moving left hand limit, what you are getting? Minus 1, it is y equal to minus 1, this is 1. At that time what? Left hand limit minus 1, right hand limit is 1, that are not equal, so we cannot draw the graph. And we cannot draw the graph by taking out the pen. So because this is discontinuous function, and if you remember what I told you, simply continuity means if you are able to draw the graph without taking out the pen on the paper, then we say function is continuous. Let's see, suppose you draw from here to here, but how you will go from here to here without taking pen? Means we have to take out the pen. So this is again discontinuous function. This is the first condition when left hand limits is not equal to right hand limits. So this is discontinuous function. So this is the first case when function is discontinuous. Let's see second case. I hope it is clear. So let's see, first case was left hand limit is not equal to right hand limit. Then we say function is discontinuous. Let's see second case. Second is that maybe left hand limits equal to right hand limits is not equal to value of function. At that time also we say function is discontinuous. If left hand limit equal to right hand limit but not equal to the value of function, then we say this is also a discontinuous function. So if you draw the graph like this, what I told you, we draw this graph, it look like this. So suppose you draw here. Suppose this is right hand limit, at this point we are checking at equal to a, but here it does not exist, it exists here. So see, left hand limit, suppose it is L1, suppose L1 and this is, and here it is L2. So left hand limits, right hand limits, both are L1, but value of function, what we are getting? L2, that is not equal. So this type also function is discontinuous. Because left hand limit and right hand limit, see, if you anybody say draw the graph, can we draw like this? Here we cannot, we have to take out the pen, again we have to draw. Means without taking out the pen, we cannot draw the graph. So we again it is discontinuous function. Let's see one example of this type of function. Let's see, suppose this is the function fx equal to, let's take a small function so that it will be easy. Fx equal to 2x plus 3 when x less than 0, x equal to 0, it is 0, x greater than 0, x square plus 3. Suppose this is the function, we have to check this is continuous or not. Which point? At x equal to 0. Okay. X, first we are going to calculate left hand limits. Left hand limit means we are proceeding from left side. So left side means limit x tend to 0 minus, means which portion we have to take? Where x is less than 0. So where it will come? This one will come, because x less than 0. So what we have to take? 2x plus 3. Now If you put here x equal to 0, what it will come? 2 into 0 minus. 0 minus means anything, we can put 0. 0 plus 3. So simply it will come 3. It is left hand limits. Now calculate right hand limits. Right hand limit, what it will come? Limit x tend to 0 plus. Right hand limit which interval? Here x greater than 0. So we will take this one. So what it will come? X square plus 3. We have to put here 0. So what it will come? 0 square plus 3 means what? 3. See here, left hand limit equal to right hand limit. Both are coming 3, 3. But value of function C, x equal to 0. F of 0, what it is coming? F of 0 is 0. So which type of C? Left hand limits equal to 3, right hand limits. So here left hand limits, right hand limit are equal. But value of function is not equal because it is 0. 3 is not equal to 0. So what we say? Left hand limit is equal to right hand limits but not equal to the value of function. So this is also a type of discontinuous. So this is also a discontinuous function. I hope it is clear. So again, if we draw the graph, see, same like this graph. Left hand limits, right hand limits are existing, but left value of function, different thing value is coming. So this is again a discontinuous function. This is the second case when function can be discontinuous. Let's see second. So if you want to draw the graph, we can draw. This is also easy. Easily we can draw the graph. So simply what it will come? Let's draw the graph so that it will be more clear. See here. Suppose this. What is this? X less than 0. We have to draw the line. What is that? 2x plus 3. So here it will up to 0. If x equal to 0, we will get 3. So here it is like that. Before that, x equal to minus 3 by 2, it will be like this. This is the line. And x equal to 0, what we are getting? Here 0 we are getting. And after that, x greater than 3, what we are getting? Y equal to x square plus 3. So what it will come? It is the parabola. It is something like this. Can we draw this graph without taking out the pen? See, from here to here, again we have to check, again we have to draw. Means again, we are not able to draw the graph of this function without taking out the pen. So simply what is that? This is discontinuous function again. Next what is the case when it is discontinuous case? 2 we have discussed. When left hand limit is not equal to right hand limit. Second, when left hand limits and right hand limit both are equal but value of function not equal. Second case will come. So this is also a discontinuous function. Let's move next, third one. Third one, when f a does not exist. Means value of function does not exist. Here left hand limits and right hand limits both are equal, but value of function may not exist. Let's see the one function like this. Suppose f(x) equal to x square minus 1 divided by x minus 1. See here, if we are going to take limits, what limits will come? Let's do here. Limit x tend to 0, left hand limits 0 minus, what it will can be? X square minus 1 divided by x minus 1. Simply we can use the formula. Limit x tend to 0 minus here x plus 1 into x minus 1 divided by x minus 1. See, here x is not equal to, here let's take at 1, we are going to check at 1. See here, if it is not 1, so here, exact not 1, so simply we can put here x tend to 1 minus. So 1 minus means, let's write 1 minus h simply. So here, x tend to 1 minus means h, here we can write limit x tend to 0 What is the here in the place of x? We can write h minus 1 minus h 1 minus h plus 1 into 1 minus h minus 1 divided by 1 minus h minus 1. See, this is cancelled, this is cancelled. 1 plus 1 we will get limit h tend to 0. 1 plus 1 2, 2 minus h, here minus h divided by minus h. So this is cancelled. We can put h equal to 0, we will get 2. So here, see, when we are able to cancel, if not equal, h not 0, we can cancel out each other. So at that time, left hand limit is coming 2. Same way, we can calculate right hand limit. Right hand limits, what it will come? Right hand limits, what it will come? Limit x tend to 1 plus x square. Same thing, up to here we can write x plus 1, x minus 1 divided by x minus 1. So simply what we have to put here? 1 plus x. So we can directly cut. If you put here 1, what it will come? 2. Left hand limit, right hand limit, both are coming 2. But let's check value of function. Put here x equal to 1. What it will come? f1 equal to 1, 1 square minus 1 divided by 1 minus 1 equal to what? 0 upon 0. Means what? Left hand limit and right hand limit both are coming equal. But here value of function not exist. 0 upon 0 undefined term. So it is not exist. So we say this is the function where value of left hand limit, right hand limit both are equal, but value of function is not equal to the left hand limits or does not exist. So here what? Left hand limit, right hand limit are equal, but value of function does not exist. So this function is again discontinuous. Say it is like that. If you draw the graph like any function, what it look like? Suppose this is the function. Here we are checking this is the a. Here left hand limit, right hand limit, but value of function not existing anywhere. So this is function which type of a discontinuous function. This is the another type of discontinuous function. So total 3 cases are there. What we have discussed, when left hand limits not equal to right hand limits. Second, when left hand limits equal to right hand limits, but value of function not exist. Next what we discussed, maybe value of function does not exist. First one, left hand limits, right hand limits not equal. Second one, left hand limits, right hand limit. Second one, left hand limit equal to right hand limit but not equal to the value of function. Third one, maybe both are equal but value function does not exist. So this is the total type of discontinuity. Now see, it is the point of discontinuity. Now a function can be asked in any interval. Suppose continuity of a function in any interval, closed interval. How to check it? Let's see it. Continuity of a function at a point we have seen continuity of a function in an interval. In an interval. Suppose if any function is given a of x in closed interval ab, if they ask it is continuous or not, so here on a we have to check left hand limits. Here at point a, here no need to, because function is defined up to a, so we after before this no need to check. So what we have to check? Right side of this. So right side means right hand limit at x equal to a, means limit x tend to a plus p of x. And here on b, left hand limits we have to check. Left hand limits means this point we have to check, because after this not. So what we have to check? Before this we have to check left hand limits of function f at x equal to b, means limit x tend to b minus of fx. We have to check if they ask in interval. At that time we have to check it is fx at a, left hand limits, right hand limits, and here we have to check right hand limits. Here no need to check left hand limit, and here no need to check right hand limits, because this function is defined in closed interval a b. Suppose let's say that this is the point, this is the point a and this is the point b. If this function define only this to this, what is the logic to change before this? No logic. So what we have to check here? We have to check only right hand limits, because no need to check here left limit. And up to here it is. So what is the means to check this side? Because this function define only this side. So what we have to check here only at b left hand limits. So if it is this, then we say this function is continuous in closed interval a b. Let's see one example. Let's our fx equal to greatest integer x. We have to check the continuity of the function in closed interval 1 to 2. 1 to 2. Okay. Now let's see. Here 1 to 2 it is the greatest integer, so we know that. So simply let's draw the graph, it will be more clear. 0 to 1 to 2 we have to draw. 1 to 2 it will be, it is 1. 1 to 2 output will be this. 2 it will be open interval. Okay. Now what we have to do? So what we have to check? We have to check their continuity in open interval. So at that point 1, what we have to check? 1 we have to check right hand limit. So limit x tend to 1 plus. Fx means greatest integer. So if you put 1 plus something, what it will come? 1. Left hand limit, right hand limit. At here what is coming? 1. And value of function f of 1, how much it is coming? 1. Now right hand and at b, what we have to check? Left hand limit x tend to 2 minus greatest integer x. What it will come? 2 minus 1.9 and something. What we can write? 2 minus h something. Limit h tend to 0. What it will come? 1. Because 1.9 and also their greatest integer 1. So what is coming? Here left hand limit coming 1. But what about 2? F of 2. F of 2. What it will come? It is 2. Greatest integer 2 equal to 2. So at that time what? See here. Here left hand limits and value of function existing. So here means at 1 equal to x equal to 1 it is continuous. But x equal to 2. Here left hand limit 1. Value of function 2. It is coming here. See this. Left hand limit here. But as you go right hand, you are reaching here. Means what? Simply again we are not able to draw the graph of this function at near to 2 without lifting the pen from the board. So again what we can say? This function is continuous where? This function continuous at x belongs to closed interval 1 to 2 open interval, because at exact x equal to 2 it is not continuous. So where it is continuous? At closed interval 1 to 2 open interval. So this is the continuity of a function in any interval. This is the all for today. This session. Next session we will see type of next continuity and we will do some question here also. Okay, thank you.